I'd like to start talking a little bit about sequences and series. So a sequence in math, as in real life, is a list of things, and they're generally going to be in some sort of order. In math, it's usually a list of numbers. So you can see below that we usually write A1 as the first term of the series, A2 is the second term, and so on. We call the nth term actually the formula. That's what we call the formula for the series. So for number 1, we are finding the first 5 terms of that series, and so we're gonna find A1, A2, A3, A4, and A5. You will find in the future that sometimes we're not going to start with A1. Occasionally we'll start with A0. And if you ever do any sort of computer program or programming or anything else with computers, you'll often find that everything will start with 0. So just keep that in mind. Make sure that you know if you're starting with 0 or 1. Okay, so for this first one, basically all we're going to do is for A1, we're just going to plug in 1 for n. So we get 2 plus 4, which is 6. A2, we do the same thing, but we plug in 2 for n. And we get 10, and so on. So you can see that it's just going to give us a pattern. You'll notice as you write out these terms that each of them ends up being added by the same amount. Like if you go from one to another, you'll find that like 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18, 18 plus 4 is 22. So you can just write it out like I just wrote here, or I usually prefer to have it written out in order in a list like this, but either way is fine as long as you know what the first 4 terms are. I'd like you to pause and see if you can do 2. So 2 is a little bit harder because we have that -1 to the n power. So keep in mind that means sometimes the -1 is going to be positive, sometimes it means it's going to be negative. So when n is 1, we are going to have a -1, so we get 2 minus 1 over 1, which just gives me 1. When n is 2, we will end up getting 2 plus 1 over 2. So it is actually going to, it's going to change signs depending on what we end up having for our n value. So that -1 will change signs. So this is just kind of a special type of problem. I forgot my 3 there, but I did get it in the end. And it's used a lot just to denote different signs. We actually call this, and when you use that, we often have what's called an oscillating sequence. In this specific situation, we actually have something that's always positive because we have it being added to 2. So the way that it oscillates is that it ends up, the numerator of the fraction switches between 1 and 3. So we will do a few examples where you have an actual oscillating sequence where sometimes it's positive and sometimes it is negative. So this one gives me 2 minus 1, and I get 1/5. I'll write out the answer, although hopefully you were able to write it out beforehand. This one is a little bit harder than the first one, definitely, because of that, the n in the exponent. But don't let that confuse you. It's just, basically, it's a way of telling if the one is positive or negative. So you'll notice I did skip 3 and 4. I went straight from 2 to 5. We'll talk about those types of problems later. There's actually a fast way to do it that is in the second chapter, or the second part of the chapter. So I'd like to go into recursive sequences. And recursive sequences, or what we actually call it recursion, are really, really common in any sort of computer programming. So if you're in AP Computer Science or you've taken any sort of programming class, you probably have heard of recursion. If you haven't heard of it, I'll introduce it now in math, but if you take any sort of computer programming in the future, you're definitely going to see recursion. So a recursive sequence is a sequence where the terms build off of the previous terms. And you'll find that you need the first term at least. Occasionally you're going to need the second term also, like in number 6. So let's do number 5 together, and then you can try 6 on your own if you want. So for this one, I asked you to write the first 6 terms. One of them has been done for you, by the way. If you really have no idea what to do, you can at least write that out. We know the first term is 6. Hopefully you can do the rest of it, though. Okay, so then we have the first term. We know that A1 equals 6. To find A2, what we're going to do is we're going to look at this formula right here, and you'll notice this formula says A of A sub k plus 1. Remember, A sub something means A subscript. In that case, our k is equal to 1 because k of 1 plus 1, or A of 1 plus 1 is going to be A of 2. So I'm going to write this as A sub 1 is equal to A1, because 1 is what k is, plus 3. I already know that A1 is 6 because they told that to me, so this is going to be 6 plus 3, which is 9. Doing the same thing for A equals 3. In this case, my k value is 2, and so I get A sub 3 is equal to A sub 2 plus 3. A sub 2 is 9, so I end up getting 9 plus 3, which is 12. You can go ahead and you're welcome to pause and finish this on your own. I'm just going to kind of work through it right now. So hopefully you can see that each term builds off of the other one. Basically what you're doing is you're taking each term and you're adding 3 to it. So that's a recursive sequence. There are actually 2 ways that you can write out the formula for this sequence. You can write this with an A sub n formula. We'll do that in the next section. Okay, so number 6, this is actually one of the most famous sequences ever. You might start seeing the pattern once you try it. So go ahead, pause, see if you can try it. I'm going to give you a hint. We already know the first term is A sub 0, and the second term is A sub 1. I know that it's weird that we're starting with 0. That happens often. For the third term, that's going to be where k is equal to 2. So, like I said, if you haven't already, you're welcome to pause and try this on your own. Okay, so basically what we get A sub 2 is equal to A sub 1 plus A sub 0 plus A sub 1, which are the 2 that we just found, and that gives us 2. To find out A sub 3, that's the fourth term of the sequence, I'm going to do A sub 1 plus A sub 2. That's going to give me 1 plus 2. And that gives me my A sub 3, which is going to be 3. You might already be seeing the pattern. If you don't, if you can't see it so far, that's fine. So then I get A sub 2 plus A sub 3. A sub 2 is 2. A sub 3 is 3. So my A sub 4 is 5. I'm gonna do one more term. These are the first 6 terms. The 5th term is actually A sub 5 is actually the 6th term. I know it's weird. So for my last one, I end up getting A sub 3, which is 3, plus 5 is equal to 8. So my overall sequence is 1, 1, 2, 3, 5, 8. If you didn't realize it, you probably have heard of this one. This is called the Fibonacci sequence. So it's a very famous sequence. In fact, I think it's the most famous sequence. If you had never heard of this, you probably want to write this down. I'm not going to necessarily test you on it, but it's just something good to know for general knowledge purposes.